Hello, and welcome to the first video in our series where we are going to explore and learn about the TypeScript language. In this video, we are going to try and answer the question, what is TypeScript? Before we get into that, I'd like to take a second to introduce myself. My name is Michael Van Sickle, and I work for a company called SitePen. We specialize in front-end web development and have become passionate advocates of TypeScript over the last few years as we've discovered how much it helps with the development of highly performant and robust front-end web applications. So let's start our discussion today by learning about TypeScript itself. The first thing that's important to understand about any language or tool that you're going to be using are the origins, because you really want to understand what credentials that tool is bringing so that you can ensure that its goals and motivations align with your own. So TypeScript's been around for a little while. It was announced in October of 2012, but it had actually been developed for 2 years by Microsoft internally before that point. And when TypeScript was introduced, it actually came into an ecosystem that had quite a few other challengers. There were several other attempts out there to streamline and improve JavaScript development, especially as front-end web applications became more and more sophisticated and were asked to do more things. Well, TypeScript came with a slightly different perspective because it sees itself as a superset of the JavaScript language instead of a separate language itself. So unlike a competitor like Dart, all JavaScript code is actually completely valid TypeScript code, and we'll explore that a little bit more. The last thing that's important to know about where TypeScript came from is the project lead. The project lead is a gentleman called Anders Heilsberg, and he's created some of the most powerful and effective languages of their time, including languages like Turbo Pascal, Delphi, and C#. So what about TypeScript itself? There's actually quite a bit packed in with that word TypeScript. For example, TypeScript comes with a transpiler. So yes, TypeScript is a language, but it eventually has to be converted into JavaScript in order to run in a web browser. So TypeScript contains a transpiler that does that work. TypeScript supports ES6 syntax. So anything that was introduced in ES6 is completely valid TypeScript. We're actually going to find that there's additional features built on top of ES6 that are available in TypeScript that in many circumstances project forward into where the JavaScript language is heading. TypeScript, as we mentioned before, is a superset of JavaScript. So anything that's valid JavaScript is actually completely valid TypeScript. And the last thing that's important to know is TypeScript is not done. TypeScript is continuing to evolve as web applications continue to evolve and additional requirements are placed on them. So what benefit do you get from adding TypeScript into your tool suite? Well, there are several language features that you get. You get type annotations with compile time enforcement. And this, as the name implies, is one of the big selling points of TypeScript. JavaScript, as you probably know, is a very dynamic, weakly typed language. So you can pass anything that you want into any function that you create, and your functions historically have had to figure out a way to manage that. Well, with TypeScript, we have these type annotations, so we get much more support from our tools to understand that we're using the different components of our application correctly. So what that boils down to is we end up spending more time writing code, less time debugging, and less time writing tests. We have the ability to do function overloading at compile time, and this is something that's just never been possible in JavaScript. But you can actually define multiple function signatures in your TypeScript code and then have your implementation of the function work through the different signatures that are allowed, giving you much more flexibility in the API that you expose to your clients. It adds interfaces to the language, very similar to C# and Java, although as you dig in, interfaces are more like C# interfaces than Java. We also get enumerations and tuples, generics, decorators and metadata, as well as namespaces in order to ensure that your code is as flexible and organized as possible. In addition, even if you're targeting browsers that don't support the latest ECMAScript standards, very often the language features for those standards are going to be available for use in TypeScript, although the functionality often is not. For example, arrow functions were added as a language feature in ES6, and those are available in TypeScript, and those can be used in ES3 and ES5 environments. However, promises are a functional change, and so TypeScript doesn't provide direct support for those. You'll need an additional tool to get access to those features. So what are the design goals of TypeScript? And this is one of the most important slides as you're starting to explore TypeScript and whether you want to add it into your application tool suite, is make sure that the design goals of TypeScript align with your design goals so that you can ensure that as TypeScript continues to evolve, it's going to continue to align with your needs. So one of the first goals is TypeScript should add no runtime overhead on embedded programs. So anything that was created in the TypeScript language should be directly converted over to JavaScript, and there should be no TypeScript feature that slows down your code at all. When TypeScript code is converted into JavaScript code, it should emit clean, idiomatic, and recognizable code. So a lot of other transpilers generate code that's perfectly valid JavaScript, but it requires a machine to read it. Well, TypeScript has the goal that if you have to get into the JavaScript and understand what's going on, it is going to be at least possible for you to understand the JavaScript code that gets generated. TypeScript has taken great pains to ensure that it aligns its evolutionary path with the current and future ECMAScript proposals. So, remember what we said at the beginning. TypeScript is not a new language, it's a superset of JavaScript that just extends it. So staying aligned with the ECMAScript standards and where ECMAScript is going is a very important design goal of TypeScript to ensure that TypeScript and JavaScript don't diverge over time. As we mentioned as one of the first benefits of TypeScript, we do get these type annotations, but those type annotations need to be fully erasable as the TypeScript is converted into JavaScript. So while there is a full type system in TypeScript, after that's converted to JavaScript, none of that type structure remains. And then the last goal of TypeScript, as I mentioned in the last slide, is that language features can be transpiled, but functions cannot. So polyfills are not going to be included in your TypeScript applications by default. You're going to need to explore additional tools such as Core.js in order to provide those polyfills for you. So how do we get TypeScript set up? Well, assuming that you have Node and the Node package manager on your system, all you need to do to get access to the latest version of TypeScript is enter this command on your terminal. So use npm install and install the TypeScript package. And that -g flag is going to ensure that TypeScript is installed globally, so it's available to all of your applications. As for developing your TypeScript applications, we do recommend, in order to get the full benefit out of the TypeScript language services, we would recommend that you explore one of these three tools. Visual Studio Code, Atom.io, or Vim are all free options. There are also quite a few other free options that are available, as well as some paid options that are going to give you full access to the TypeScript language features. The next step for setting up your TypeScript project is to create a file called the tsconfig.json file. What this is going to do is there are a lot of commands that you can pass into the TypeScript compiler. Well, if you're passing in those same command options every single time, the tsconfig file allows you to centralize those. So all you have to do is run the compiler and it will read this configuration file and generate your JavaScript files according to those rules. So you see here at the bottom of the slide, we do have an example of a tsconfig file. A couple of things that are interesting to point out is we have the exclude and include arguments. These are additions to the tsconfig file that have been added over the last few versions of TypeScript and really help. The exclude array acts like you might expect. Any directory that's specified in that array is going to be excluded from your build. And conversely, the include argument includes a list of directories and files that will be specifically included in your build. So when you want to invoke the command line compiler in order to convert your TypeScript code into JavaScript, then you're going to use this command here. If we use TSC, which stands for TypeScript compiler, and pass the -p flag, it's going to look in your current directory for tsconfig.json file. It's going to pull those options from it, and it's going to follow those rules in order to convert your TypeScript over to JavaScript. The next thing that I want to talk about is TypeScript's type system. So let's get into that. So we're going to go through this at a high level, and as we go through this video series, we'll dig in deeper and learn quite a bit about TypeScript's type system. But for now, let's just take a high-level overview and see the big blocks that we have to work with here. So here's your first example of some valid TypeScript code. At the top, you see a snippet of TypeScript with some type annotations here. So on line 1, you see that we're declaring a variable foo that's of type string, and we're assigning a value foo to it. On line 2, we're defining a constant called bar, and it's defined as an object that has one field, foo, that's allowed to contain a string, and then we're initializing that object with the field foo and initializing it to the value bar. Now, since we have that constant initialized, we can, of course, assign the foo field to the foo variable. So we're changing that string bar to the string foo, but TypeScript's compiler is going to generate an error if we try and assign a number to it. However, if we try and transpile this TypeScript into JavaScript, we get the code that you see down below. Now notice all of the types are completely eliminated. We don't see any mention of the string types anymore because that's not valid JavaScript code. And also notice line 4 did get included in the build. So by default, TypeScript is going to generate errors and warnings if you're doing something that the type system is going to generate an error for, But TypeScript, again, by default, is not going to prevent you from generating that JavaScript code. And this is just to ensure that if your type annotations don't fully model your environment, you do have the flexibility to still generate the JavaScript application. However, we do advocate that any of these TypeScript errors should be considered as real errors, and the JavaScript that gets generated should not be used, or you should update your tsconfig to not even generate that JavaScript if you have a typing error in there. So how does TypeScript's type system work? Well, there's really two major players in the typing world. There's what's called duck typing, or more formally called structural typing, and there's nominal typing. TypeScript uses structural typing, which basically means if the structure of an object aligns with what the type system says it's looking for, then it will be considered an instance of that type. Now, if we look at another language, such as C# or Java, we're going to see instances of a nominal typing system. So in C# or Java, if you declare an object to be of type foo, then it is only considered a foo object if it has been instantiated as that. So any other objects that have the same fields and methods as foo cannot be used interchangeably as a foo in C# or Java, but in TypeScript, they could. Now here's an example of how TypeScript's duck typing or structural type system works. Let's just say we have a class A that's got a field foo that we initialize to bar. We also have a class B that has the same field and is initialized to the value foo. Well, if we instantiate a variable, lowercase a, like you see on line 9, as a new instance of A, then we have an object that's got a field called foo and a value bar. Now, if we take A and assign it to a new B, that's actually completely valid in TypeScript, because the structure of the A class and the B class are the same, and therefore they can be used interchangeably. Now, an extension of this is when we do this cross-assignment, we need to maintain the minimum structural contract. So let's take a look at this example here. Now we've got the class A that's got a field foo initialized to the value bar again, and then class B is a little bit different than on the previous slide. This class extends A, so it's going to inherit that foo field, but it's going to gain an additional field called bar. Now on line 9, we initialize the variable A, and the type of A is capital A, like we might expect. We can also reassign A to a new instance of B, and that's still going to work, but the variable A is still typed to be of type capital A. So if we try to do what you see here on line 11 and access the bar field, even though the A object, since it's an instance of a B class, has a bar field, the type system's not going to recognize that because it's already set the type of A up on line 9 as an A class. Now, another thing that was added in TypeScript 1.6 is this check for excess properties. And this is only done when an object is fresh or when it's first created. So as you can see here on lines 1 through 3, we have a function foo that's going to accept an object that contains one field called foo that's of type string. And it's going to take that argument in as a local variable called value. Now, when we call the foo function on line 5, we actually pass an object in with two fields, foo and bar. And as you can see here with the comment on line 7, we're actually going to get a TypeScript error here. And that's because the object structure that's looked for by the foo function doesn't contain a bar field, but we've included one. And that's going to be a problem for the type system. Similarly, if we have a variable bar, like you see here on line 10, that has one field foo of type string, and we try and instantiate that object, we get exactly the same error for exactly the same problem. We're trying to assign an object to a variable that has an excess property, and so therefore the type system is going to have a problem with it and generate an error. Now remember, one of the goals of TypeScript is to be a superset of JavaScript. That means that any valid JavaScript should also be considered as valid TypeScript. One of the ways that TypeScript does that is that any variable that doesn't have a type declaration is considered the type any. And you can do, well, anything with any, because TypeScript's type system basically goes to sleep and lets you pass whatever you want in here. So as we have a function defined here on lines 1 through 3, where we got foo of value, and we're just using that variable on line 2, we're not actually doing anything that's going to constrain that. Well, all of the lines that you see, lines 5 through 8, are completely valid. We can pass a string here, we can pass an object literal, we can pass a regular expression, or we can pass nothing at all. And TypeScript is going to be completely okay with that, because again, we have got no information that we're providing to the type system, letting it know what type of data the value argument should hold. Now this could be nice if you're converting a JavaScript project over to TypeScript, because you're not going to get 15,000 errors, but just keep in mind, You don't want to use this too often because as soon as you go to the anytype, TypeScript's type system can't help you because it has no information and can provide you no help with what data types should be assigned there, and so it can't provide any typing assistance for you. Now, TypeScript does offer what's called a strict mode. And if you turn this on, then that code we were looking at in the last slide is actually no longer valid TypeScript. And that's because the implicit any gets turned off in strict mode. So you see here our function on line 1, that's exactly the same function we saw in the last slide, and that's no longer going to be valid TypeScript because we can't have an implicit any anymore. However, the function bar that's declared on line 5 is completely valid because we're explicitly saying that we're going to accept the any type, and so anything's going to be accepted by this bar function. Another advantage that strict mode brings is if you have an optional type. So for example, we have in this function foo, value with that question mark. That question mark means that the value parameter may or may not be provided. So if it's not provided, then the value variable is going to have the type undefined. And undefined doesn't have a length property like we see on line 2. So if you're in strict mode, then you're going to see that this is going to generate a TypeScript warning, because if value comes in as a string, then we can pull the length property off of it with no problem at all. However, if it comes in as undefined, so the parameter isn't provided, then we're going to have an error in our application. So that's just an overview of strict mode. We're actually going to come back to strict mode later in this series quite a bit as we get into more detail about the specific features of the TypeScript language. The last thing that we're going to cover in today's video are some of the basics of working with TypeScript. So let's start by talking about transpilation. Now there's a couple of different terms that you might hear used for the transpiler in TypeScript. The TypeScript documentation actually calls it compilation, but we prefer to use the word transpilation because we're actually transpiling from one language, the TypeScript language, over to the JavaScript language. So we're not compiling down to machine code, we're actually converting from one language to another, so we use the term transpilation, which is the common term used in the industry. Now there's some advantages that come from the fact that we've got a transpiler involved in our TypeScript projects, and we've talked about those a little bit in the previous sections, but I want to come back and hit those in a little bit more depth here. First of all, since we have a transpiler, TypeScript has an opportunity here, because it doesn't just have to convert to one version of ECMAScript. We actually have a variety of ECMAScript levels that TypeScript code can be down emitted into. So, for example, by default, the TypeScript compiler tries to generate your code down as ECMAScript 3. However, you can configure it to generate ECMAScript 5 compatible code, 2015, 2016, 2017, or any future version. Now, the advantages of going with the higher versions of the ECMAScript standard are, of course, you get the ability to use the more modern language features, and your code is probably going to execute faster. However, if you're constrained to deploy to legacy environments, then the ability to down emit down to even ECMAScript 3 in many cases is a huge advantage for your organization because it allows you to use the advanced language features that TypeScript supports, but still be able to deploy to those legacy environments. Additionally, the transpiler allows us to deploy to multiple different loading formats. So for example, TypeScript modules can be compiled to use the CommonJS standard, AMD, UMD, and the various other standards that you see here. As we've mentioned before, the TypeScript transpiler allows us to use syntactical features from current and future ECMAScript standards and down emit those to work in environments that don't support those standards yet. Now, just to remind you, syntactical features are supported, but functional fills are not provided by TypeScript. So if you need those polyfills, you're going to have to go to another library, again, such as core.js, to provide those polyfills to allow you to use those advanced functional features in your legacy environments. But some of the syntactical features that we can take advantage of are listed here. So we see the object rest and spread properties, class fields. Even though those aren't part of the standards yet, we are able to use class fields. We can use optional catch binding, and we can use class and property decorators, although since the ECMAScript standards have been evolving a little bit, the TypeScript definition of how to use class and property decorators is a little bit out of sync with where the ECMAScript standard is currently headed. Now, if you do need to support legacy environments, keep in mind, TypeScript does not provide those functional fills. However, you can use a library such as core.js to provide features such as promises, maps, sets, and symbols, as well as quite a few other functional features that have been added into the ECMAScript standard, but are not directly supported by TypeScript. And the final thing that I want to cover is just to reiterate this notion that TypeScript is a superset of JavaScript. So you see in the graphic here where we have right at the center bubble in that light yellow, we see JavaScript ES5. And that's the most popular version of JavaScript that's out in the market today. And then added on top of that in 2015 was the ES6 standards and the additional standards. And those are superscripts of the ES5 standard. They didn't replace any of the standards in ES5 or before, they added to it. Well, TypeScript tries to do the same thing. So it has the goal of encompassing all of the current ECMAScript standards, supporting those, as well as providing additional features and functionality, such as type annotations, call flow analysis, and things like that we'll explore as we go through this video series. And that brings us to the end of this first video, where we explored what is TypeScript, what is the language, what supports the language, and how can it be used in your applications. If you've gotten a lot out of this video and you want to stay in touch with us to learn more about what SitePen's doing, then I would encourage you to reach out. We're available on various forms of social media, so you can reach out on Twitter, Facebook, or LinkedIn. And you can also sign up for our newsletter using the URL that you see at the bottom of your screen. Okay, that wraps up what we have to talk about in this video. If you have any questions, please feel free to reach out to us. We'd love to start a conversation with you. Until next time, this is Michael Vansickle wishing you luck in all of your development endeavors.